If two different circuits share the same neutral on the same phase, several potential issues can occur. Firstly, increased neutral current can occur. When circuits share a neutral, the total current flowing through the neutral is the sum of the currents in all the connected circuits. This can overload the neutral wire, causing it to overheat and potentially leading to a fire hazard. Secondly, voltage imbalance can occur. If the loads in the two circuits are not balanced, the voltage across the neutral can become unbalanced. This can result in voltage fluctuations and power quality issues, which can affect the operation of sensitive electronic devices. Thirdly, ground fault circuit interrupter, or GFCI misoperation may occur. Ground fault circuit interrupters are designed to trip when there is a difference in current between the hot and neutral wires. If two circuits share a neutral, the current returning to the panel may not match the current flowing in the hot wire, causing nuisance GFCI trips. Fourthly, voltage drop can occur. Sharing a neutral can increase the voltage drop, especially if the circuits are connected via a long wire. The voltage drop can reduce the voltage available to the connected devices, affecting their performance. Fifthly, a safety hazard exists. In the event of a fault on one of the circuits, the neutral current may increase, creating a potential shock hazard if the neutral wire is not properly connected to the grounding system. To avoid these issues, it is recommended to separate circuits onto different neutrals. While it is possible to share a neutral in some cases, it should only be done in specific circumstances, such as in multi-wire branch circuits where the currents are balanced and the neutral is properly sized to handle the total load. The neutral wire, also known as the grounded conductor, plays a crucial role in electrical circuits. Its primary function is to provide a return path for current to the source, typically the electrical panel. In a properly functioning circuit, the neutral wire carries the unbalanced current, which is the difference between the current flowing through the hot wires. When two separate circuits share the same neutral wire, several adverse effects can arise. The most significant concern is the potential for overloading the neutral conductor. According to electrical codes and best practices, each circuit should have its own dedicated neutral wire to ensure safe and reliable operation. When multiple circuits share a single neutral, the neutral wire may not be adequately sized to handle the combined current from all the connected circuits. This can lead to overheating of the neutral wire, which poses a significant fire hazard. The increased current flow can cause the insulation surrounding the wire to melt, potentially resulting in a short circuit or electrical fire. Voltage imbalance is another issue that can occur when circuits share a neutral wire. In a balanced electrical system, the voltage across each phase should be equal. However, when circuits with different loads share a neutral, the voltage distribution can become uneven. This imbalance can cause voltage fluctuations in the connected devices, leading to poor performance or even damage. Sensitive electronic equipment, such as computers and audiovisual systems, are particularly susceptible to voltage fluctuations and may not operate correctly if the voltage is not stable. Ground fault circuit interrupters are essential safety devices that protect against electrical shock. GFCIs work by monitoring the current flowing through the hot and neutral wires of a circuit. If there is a difference in current indicating a ground fault, the GFCI will quickly trip the circuit to prevent electrical shock. However, when two circuits share a neutral wire, the GFCI may not function correctly. The shared neutral can create a situation where the current returning to the panel does not match the current flowing through the hot wire, causing nuisance tripping of the GFCI. This can be frustrating and inconvenient, as the GFCI may trip even when there is no actual ground fault. Voltage drop is another concern when circuits share a neutral wire. Voltage drop refers to the decrease in voltage that occurs along the length of a wire due to its resistance. The longer the wire and the higher the current, the greater the voltage drop. When circuits share a neutral, the increased current flow through the neutral wire can exacerbate voltage drop. This can result in reduced voltage at the connected devices, affecting their performance. For example, lights may dim, motors may run slower, and electronic devices may malfunction. In addition to these issues, sharing a neutral wire can also create a safety hazard. In the event of a fault on one of the circuits, the neutral current may increase dramatically. If the neutral wire is not properly connected to the grounding system, this increased current can create a potential shock hazard. Anyone who comes into contact with the faulty circuit or the shared neutral wire may be exposed to dangerous voltage levels. To avoid these problems, it is generally recommended to provide each circuit with its own dedicated neutral wire. This ensures that the neutral wire is properly sized to handle the current from the circuit and that voltage imbalances and GFCI misoperation are avoided. However, there are some exceptions to this rule. In multi-wire branch circuits, it is permissible to share a neutral wire between two circuits if certain conditions are met. Multi-wire branch circuits are commonly used in residential wiring to provide 120 volts power from a 240 volts supply. In a multi-wire branch circuit, two hot wires from opposite phases share a common neutral wire. The key to safely sharing a neutral in a multi-wire branch circuit is to ensure that the currents in the two hot wires are balanced. This means that the loads connected to each hot wire should be approximately equal. When the currents are balanced, the neutral wire will only carry the difference in current between the two hot wires, which will be much smaller than the total current. It is also essential to properly size the neutral wire to handle the maximum possible unbalanced current. In addition, it is important to use a double-pole circuit breaker or two single-pole circuit breakers with the handle tied to protect the multi-wire branch circuit. This ensures that both hot wires are disconnected simultaneously in the event of a fault. Sharing a neutral wire between circuits on the same phase is generally not recommended due to the potential for overloading the neutral conductor, voltage imbalances, GFCI misoperation, voltage drop, and safety hazards. It is best to provide each circuit with its own dedicated neutral wire to ensure safe and reliable operation. While multi-wire branch circuits are an exception to this rule, they should only be used if the currents are balanced and the neutral wire is properly sized. Understanding the principles of electrical circuits and adhering to electrical codes and best practices are essential for ensuring the safety of electrical systems. Electrical safety is paramount and is critical to prevent potential hazards associated with improper wiring configurations. Here are some additional details regarding the potential issues arising from sharing a neutral between circuits on the same phase. Firstly, consider the issue of harmonic currents. Nonlinear loads, such as electronic devices and appliances with switching power supplies, generate harmonic currents that flow back to the source. These harmonic currents can add up in the neutral conductor, especially in shared neutral configurations. The increased harmonic current can cause the neutral wire to overheat, potentially leading to insulation damage and fire hazards. Secondly, regarding the topic of voltage regulation, when multiple circuits share a neutral, the voltage regulation can be negatively affected. Voltage regulation refers to the ability of an electrical system to maintain a stable voltage level under varying load conditions. Sharing a neutral can lead to voltage fluctuations and voltage drops, which can affect the performance of sensitive electronic equipment. Thirdly, you should be aware of electromagnetic interference. Sharing a neutral between circuits can also increase the risk of electromagnetic interference, or EMI. EMI is unwanted electrical noise that can disrupt the operation of electronic devices. The increased current flow in a shared neutral can radiate electromagnetic fields, which can interfere with nearby electronic equipment. Fourthly, related to troubleshooting challenges, troubleshooting electrical problems in circuits with shared neutrals can be more difficult than in circuits with dedicated neutrals. The shared neutral can create complex current paths, making it challenging to identify the source of the problem. Technicians may need to use specialized equipment to trace the current flow and isolate the fault. Fifthly, compliance and code requirements must be followed. Electrical codes typically require that each circuit have its own dedicated neutral wire. Sharing a neutral between circuits in the same phase may violate these codes, leading to fines or other penalties. It is essential to consult with a qualified electrician to ensure that all electrical work is compliant with local codes. Sixthly, let's discuss best practices. The best practice is to provide each circuit with its own dedicated neutral wire. This ensures that the neutral wire is properly sized to handle the current from the circuit and that voltage imbalances and GFCI misoperation are avoided. While multi-wire branch circuits are an exception to this rule, they should only be used if the currents are balanced and the neutral wire is properly sized. Seventhly, what about the implications for energy efficiency? Sharing a neutral can reduce energy efficiency. The increased current flow in a shared neutral can lead to higher line losses, which means that more energy is wasted as heat. This can increase electricity bills and reduce the overall efficiency of the electrical system. Eighthly, you should know the proper methods of neutral sizing. Proper neutral sizing is essential for ensuring the safety and reliability of electrical systems. The neutral wire should be sized to handle the maximum possible unbalanced current. In multi-wire branch circuits, the neutral wire should be sized to at least the same size as the hot wires. Ninthly, the importance of grounding must be considered. Grounding is an essential safety measure that protects against electrical shock. The neutral wire should be properly connected to the grounding system to provide a low impedance path for fault currents. This helps to ensure that GFCIs will trip quickly in the event of a ground fault. And tenthly, be aware of the implications for electrical inspections. Electrical inspections are conducted to ensure that electrical work is compliant with codes and standards. Inspectors will typically check to see that each circuit has its own dedicated neutral wire. Sharing a neutral between circuits and the same phase may result in a failed inspection. Always consult with a qualified electrician before performing any electrical work to ensure that it is done safely and correctly. A licensed electrician will be able to assess the situation and make recommendations on the best way to wire the circuits. They can also ensure that the wiring is compliant with local codes. Ignoring these considerations and improperly sharing a neutral can lead to dangerous situations and costly repairs. It is always best to err on the side of caution and follow the recommendations of a qualified electrician.